Get started. Okay, so as you saw from my email, I kind of reorganized the course structure a bit. So I'll just go over it. Hopefully it was clear. So last week I happened to have the 2 social engineering lectures recorded from a previous year, and so I thought I would just give it to you. You wouldn't have to come into campus the week before reading week. So I had 2 options. One is that I could have had you watch half of them that week and the other half this week, but because they're kind of continuous and kind of like one chunk and you had reading week and things like that, I thought, why don't I just give them both to you to watch, even though it's double. I know it's double the amount. And then what I'll do is I'll cancel the last class. Okay, so I'll make it back to you. I'll make it up to you by canceling the last class. So this class will end a week earlier than all of your other classes. And trust me, at that time of the year, you're going to have final projects. You're going to have starting to think about studying for final exams and things like that. And you'll probably be grateful. Hopefully, that's my hope down the line. If you weren't able to watch this because it was too much, it's not a problem. You can wait till that last week that gets canceled to watch it. It doesn't. Your assignment 2 doesn't depend on it. Nothing depends on it other than the final exam. But the advantage to watching it now is that you can ask me questions about it. If you wait till the end, then you won't be able to ask me any questions that you might have. Okay, so I will take your questions about that in a second. The other thing I wanted to say is the other reason I like this plan is it moved up today's lecture and next week's lecture. And next week's lecture is the most important for assignment 2. What you do in assignment 2 is what we covered. We'll cover the theory of it this week. Next week, I'll give you an actual example of what's called a cognitive walkthrough, and then you'll be doing a cognitive walkthrough in your assignment 2. And so now you'll have an extra week between seeing me do a cognitive walkthrough and you having to do your own for assignment 2. So that also was beneficial. Okay, so this week we won't have class. Maybe I can add a little more language to the Moodle to make that clear. And the other thing I want to draw your attention to is the exam schedule came out in tentative form. So we can look and see where we are. So normally they pick, like since the class is on a Wednesday, they'll pick a Wednesday. Usually they do it the first week after class ends. I think this might be 2 weeks because I see some other exams on Wednesday, December 4th, and it's roughly at the same time. What does tentative mean? It basically means that, like, unless if a student happens to have a conflict with that, and so a conflict would be you have another exam at literally the same time, then they'll move one of the 2 exams. Or if you have 3 exams in the same day, that's also considered a conflict. Having 2 exams is not considered one, which probably you're not going to have another exam, at least not in our department, unless if you're taking this particular course, but it's in quality engineering. But anyways, some years there are students that do have 2 exams in the same day. It sucks to be that student for sure, but it's not considered a conflict by Concordia, so they won't move an exam. So this is probably, you can think of it as like 95% sure, but still there is a 5% chance that it might move. So you might want to still hold off on, like, if you're going to be booking airline tickets or that kind of thing to take off at the end of the term. The room number isn't announced. I think I probably have it in my email, or eventually they give it to me. Usually with a class this size, it gets split up. It's usually in these rooms, like in Falberg somewhere, and you might get split up between a couple rooms, but closer to the exam, I'll go through all those details. And usually it's just alphabetical. So if your last name is between A and M, you go to this room, and otherwise you go to the other room. Okay, any questions about logistics? No? Yep.
Those sessions that you said that you recorded online.
Yeah.
For session 6 and 7.
That's right, yeah. Yeah, exactly, yeah. So now the naming convention is, well, yeah. So I'm calling this week lecture 8, even though it's the 7th lecture, I'm calling it lecture 8, yeah. But specifically, so if you go to YouTube, these are the ones that you should have been watching last week or the week before. So there's it's split up into 5 videos because I have these 2 clips, And I could have embedded the clips in the video itself, but YouTube sometimes gets mad about that and they give you copyright notice. So I thought it was safer to just have them split out. And then also like having I think I tried to play it, but then the audio didn't go through because you're like recording your voice and you're recording this, and then you have to record your computer audio and stuff. And so it was just easier to split them out. And the two videos were on YouTube already. So anyway, anyways, if you click on this, it will play through like a playlist on YouTube, and it will just go through all the 5 videos. Okay, is there any questions about the actual content of that? Or it was clear, or we didn't watch it yet? Anyways, okay, if you haven't watched it and you're going to watch it later and you have questions, obviously any class you can ask me questions about this stuff, but do try and catch up on it because it will be on the final, and it is a lot. Like it's more than 1 week's worth of lecture to go through. Okay, any questions about anything before we jump into the lecture?
Some stories about your own technologies, because I saw this scam. For me, it's an old school scam, because the new technology, I heard that somebody break the two-factor authentication with the cloning a voice. From a high director, they clone the voice and it could make it scam.
Right.
So this is just voice, but maybe in the near future will be even live video.
Correct.
So there is some studies that are really studying how to avoid that, or
Yeah. So there's no good answer. You have to think attack and defense. So like the defense is like, if you're talking to me on the phone, how do I even know who you are? Right? And I can make you turn your video on, but it could be an AI, or it could be a human like doing the voice and the facial expressions, but then it's overlaid with your face, like a sort of hybrid, human AI hybrid. Like you've probably seen those like Tom Cruise videos or whatever. But yeah, so like the answer is like you're not going to be able to do authentication very well. It's getting harder and harder to do it remotely, and the solution will either be it's too expensive for everyone to do it easily, and the number of people that do it is in the small, like less than 1%, and so we'll just tolerate it. So there'll be some level of fraud because it's sophisticated, and that will get worked into the prices of everything. That's the sort of one path forward, or the other path would be like some more sophisticated authentication or requiring things in person and that type of thing. Yeah. But anyways, as people who will be looking to get jobs in security, it's a good problem for you because these things aren't going to go away. They're going to get worse. Okay, anything else on the lectures? Okay, so we'll jump into the next topic. Okay, so the next thing I want to talk about is usability. So we've seen usability already as one of the columns that we used in our UDS frameworks for evaluation frameworks. But it's one thing for you to come up with a column and say, oh, I think this gets a full dot or this gets a half dot or a no dot. That's like you're at least thinking about what the usability issues are. But what if you want to be really, really sure? You want to be certain that users can use the system or whatever the property is exactly that you're trying to achieve, then what can you do? So that's what this lecture's and next week's lecture will be about. So I'll show you 3 methodologies that it can be used for usability, and then in assignment 2, you'll do one of them. Okay, now why study usability in a security course? Okay, so imagine that I have like some new tool and it actually is more secure. It's a better way of authenticating people remotely, or it's a better password scheme or whatever. And it legitimately is more secure. But if it's harder to use for the user, then users might not use it. Okay, so even though I came up with something that was more secure, unless the people actually use it, I didn't actually make the world more secure. Okay, so our goal isn't to just dream up things that are more secure. our dream is to like make the world more secure, which means that people have to use the things that we dream up. Okay, and so you need to balance two things. You need to make an improvement on security, but you also have to make an improvement in a way that it continues to be usable. Okay, it's fine if it's harder to use. Harder to use is fine. Okay, but it can't be so hard to use that users stop using it. Okay, then you go too far, and then you might as well not have done anything at all. Okay, so things that go wrong when things are too hard to use. Users make a lot of errors. They're trying to do it. Think about two-factor, like maybe not so much now because it's a lot of clicking and copy and pasting, but like before you would actually have to type the code in, right? And so you might mistype a character, so that's an error. Users will try to avoid using it, okay? And if they have the option, part of that avoidance might be to do something insecure instead, okay? So you might actually make people more insecure in the long run because they hate using your system so much that they find some way around it, some way to shortcut it, and because they find that, then it's even less secure, okay? So like I'm trying to think of a good example, but it might be like say there was some like just security on a door and you had some fancy thing where you had to like prove who you are like to get inside the door. People might get so frustrated that they just leave the door propped open. Okay, so now it's even less secure than it was before you rolled out your security technology. And so anyway, so that's another problem with usability. Security is usually the secondary goal, or it always is. Nobody sits down and says, I want to be secure today, or like my goal is to go do something as securely as possible, okay? Your goal is to get the thing that you want to do done, and then if you can do it in a secure way as opposed to an insecure way, that's better, okay? So that's your secondary goal. But your first goal is just to get done whatever it is that you want to get done, okay? And if the security is going to stand in your way of getting that done, then you might think about doing it in other ways that aren't so secure. And so we'll see this in sort of the methodology that you end up using in assignment 2. It's very oriented around this principle of thinking about how users complete tasks. What are the tasks that users actually want to do, and what are the steps that they would do to complete it, and how's that going in terms of usability? That's essentially what you'll be doing in assignment 2. Another thing that's popular in security and privacy, we've already seen it. We looked at SSL and HTTPS, and we saw like sometimes there's errors, right? Like a certificate is revoked, or the domain is mismatched, or it's self-signed, or something like that. And so one thing that you can do is you can always throw it to the user. The computer can say, I'm not going to decide this for you. Maybe you're getting attacked, or maybe someone just forgot to renew their certificate. I don't know. I don't want to decide that for you just in case you are getting attacked. So I'll try and get you to make that decision. And so I'll show you a warning, or I'll show you some sort of error message or something like that. You can decide what you want to do. If you design your software in this way that it's always bugging the user to make security decisions, users get fatigued very quickly, and then they start just clicking allow, 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 allow. Okay, they're not even thinking anymore about what decision they're making. They're just trying to swat away the error or the warning message. Security is best when you don't have to present the user with any decisions, okay? So if you can make the secure decision automatically in the background, the software just does it, that's the ideal, okay? You can't always do that. I'm not saying you can always get there, but to whatever extent you can try and automate security decisions, then that's going to be a principle that makes the software more usable. The software should guide the user and provide feedback. So it used to be the case, sorry if I had a picture, but I don't. Okay, let's say that when I was growing up, you would go and you would get some software like, say, Microsoft Word, or whatever it was called back then. I think it was called Word. And you would get it, it would come on like a CD-ROM, and there would be this manual that would come with it, like a book, right? And it would tell you how to do everything, okay? And the thought at the time was that that's how users actually learn how to use software. So before you fire it up, you're going to sit down and you're going to thumb through the manual. You might not read every word of it, but you're going to read a bunch of it before you even try to use the software. Okay? So that's how developers thought about how users should use their software. Okay? And eventually along the line, people realized people don't read the manual. And so maybe the software should help you itself, right? Maybe you should be able to just fire it up. And when I have in my mind, like, I want to make this text bold, you know, there's a toolbar and there's something called bold, or there's like a font that looks bold, and visually I can sort of figure out how to use it. So I can kind of figure it out as I'm using it. Maybe there's like, if I hover my mouse over things, it explains things to me, that type of thing. Okay? So that's a sort of alternative that is a good principle to follow for usability, is try to not assume that the user is going to read a whole bunch of stuff before they use it, but you want the user interface itself to guide the user and get them to make the correct decisions as they're using it. If you are in a corporate environment, you know, somebody codes up the software, they're going to think it's super usable out of the gate, right? They understand it fully. They have the right mental model of exactly how the software works. They developed it. To them, it is easy because they're an expert in it, okay? And so it's really hard for you to go to your developers and say, make it more usable. Like they can't even understand why it's not usable in the first place, okay? So the best approach you can do is bring in actual outside people. Bring in your real users if you can. If you can't, you could bring in random people off the street to use it. If you can't do any of that, you could at least bring in an expert who knows about usability and is kind of well-versed in putting themselves in the shoes of a novice user and have them go through the software, okay? So just because the developers say, oh, it's usable, that doesn't mean anything. Defaults are very, very important. So most users, another thing, so it sort of goes along with this. Sometimes the software doesn't want to make security decisions. So it can show you warnings and prompts and ask you about things. That's one way forward, okay? Another way forward that sort of goes with security works best in the background is we'll make a bunch of decisions for you, and that will be the default. And if you don't do anything, then those are your decisions. But, you know, buried in the settings menu, there is the chance for you to go through and change things that you really don't want, okay? Now, I probably don't have to tell you that most users will never change the default settings, okay? They're just going to roll with whatever it is. We see it on social media, you see it in software, lots of different places. You even see it in real life. I have an example of that, but anyways. And then the final thing is that when you use software, you have to understand how it works to some extent. And not just software. I keep saying software. Let me give a sort of blanket disclosure. Usability is for everything. Everything that you use has a usability component. It can be hardware, it can be software, it can be a device, it can be an item, it can be a vehicle, whatever. Okay, so usability plays in all of that. It's best studied, or it's most studied in academia in terms of software. So most usability concentrates on software. So often I'll start talking about software, but when I do, just think that I'm not limiting myself to software, so it applies to lots of other things as well, okay? But anyways, in order to use something, you have to have a basic model of how it works, okay? But that model does not have to be correct. As long as it makes the user make the right decision, then that's fine. Okay, the user doesn't have to actually truly understand what's going on. They just have to understand enough that they can make the right decision. Okay, so this is a shortcut that you can do because you can't teach the user everything. You can't make users experts. So you have to find, if you can find some other model of things that users do understand and kind of use it as an analogy for what you're doing, that might be a way to try and get them to make the right decisions without necessarily fully understanding. Okay, so here's some examples of things. So going back to the idea of defaults. Okay, so this is a chart. This has nothing to do with computer science. It's just it comes out of sociology. It's from this book, Nudge by Thaler and Sunstein. Okay, so you see a graph. There's a bunch of countries along the bottom. So you have Denmark, you have Germany, you have Austria, you have France. they're measuring something, whatever they're measuring is very low in these 4 countries, and it's very high in these countries. Okay? Now, what this is measuring is how many people agree that if, say, something tragic happens and you're in a car accident and you die, would you agree to let your organs be used to donate to someone else that needs one? Okay? Now, why is it so low in these 4 countries and it's so high in these other countries? Okay, so you might look at it and say, well, maybe there's a difference. Maybe the culture is different in these countries, or maybe the people are different. But these countries are all like pretty close, like they're geographically close. A lot of the culture is the same. If you look at a country like Germany and Austria, you know, there's a lot of Germans in Austria, right? There can't be that much of a cultural difference between these 2 countries. Okay, so that probably isn't the explanation. So what they did in the book is they realized, well, actually, the big difference between these countries is in order to be an organ donor, you have to do something. Okay, you basically, you decide whether you are when you get your driver's license. That's where it's handled. And in the first 4 countries, if you do nothing, if you just fill out your driver's license form, you will not be an organ donor by default. But if you want to be, you can still do it, but you have to fill out an extra form that basically says, I will be an organ donor. And in these countries, it's the opposite. You fill it out, by default, you're an organ donor. You don't have to be. You can opt out of it, but you have to fill out an extra form in order to opt out. Okay? So what do people do? They do the default. Okay? So in countries where the default is to not donate, most people don't donate. And in countries where the default is to donate, lots and lots of people donate, like nearly 99% in a lot of these countries. Okay, so this is just an illustration of defaults. Most people aren't going to deviate from them. Even if they have beliefs about what they want, they just won't put in the effort to do it. Here's another example for mental models. So a car is a good example because a car is like pretty complicated. Okay, it's a pretty complicated thing. Different cars have different complexity levels, right? So you might have a car that's very mechanical. You might have a car that's basically a computer on wheels. But anyways, now a lot of us can drive. Okay, do we have to understand how the internal combustion of an engine works in order to drive? Okay, we don't have to. Okay, so this is an example of a mental model. So we have a certain mental model of like, I press the gas button and the car goes, right? That's not an accurate or correct mental model, but it's good enough and we can drive as a result of being able to do that. Okay? Another simple thing would be if I turn the steering wheel to the right, the wheels turn to the right. If I turn the steering wheel to the left, the wheels turn to the left. Okay? That's a mental model. Is that mental model correct? It could be. So in mechanical cars, it is, like the steering wheel is actually like physically attached. But in modern cars, it's not. It's just a computer. So when you turn the steering wheel, it sends a signal to a computer, and the computer basically says, oh, the person wants to go this way. And then it will do whatever it takes to get them to go that way, which would be like turning the wheels. Okay? So that a lot of cars would be like that. Now, is there ever a case where I want to go this way, so I'm going to turn my wheel this way. Sorry, my steering wheel, I'm going to turn it this way because I want to go this way. But the car will actually turn my wheels the opposite way. Could that ever happen? Okay. Yeah, so there are scenarios where usually when you lose traction. So like say you're skidding, and what you want to do is you want to bring your wheels into the skid, regain traction, then pull them out of the skid. And so what your car is saying is, when I go like this, it's not saying I literally want the wheels to turn. It's I want the car to go in that direction, right? If the car decides I need to go this way first, regain traction, and then go this way, it will make that decision for you, unless if you turn off traction control, okay? Which is what race car drivers do. First thing they do is they turn it off because otherwise the computer gets very confused because they do want to skid around and not have the car try and meddle with what they're doing. Okay, so sometimes having a wrong mental model, like if I turn the wheel, the wheels go, is actually the better thing. You don't want to explain to users, well, there's this traction control and all that stuff. Like, who cares? right? Just, turn the wheel in the direction that you want to go, and that's good enough, okay? So security is kind of like that. There's a lot of details that the user just doesn't have to care about, and they can even be exactly wrong about it as long as the security, as long as their security is being taken care of and it's making the right decisions. Okay, so how do we go about analyzing usability? So you have a new product and you want to test whether users can use it or not. What do you actually do? So there's there's probably lots of different methodologies, but most people do one of three things, okay? The first thing you can do is you can try and evaluate it yourself, or maybe you hire someone or you have someone that's specialized in it. But basically some sort of expert can sit down and try and figure out whether it's usable or not. So we call that expert review. The second thing you can do is you can bring in either your users or people off the street, whatever, and you can bring them into sort of a laboratory study, and you'll make them use the software, and you'll watch them and take notes and measure like the amount of time it takes and all whatever you want to do with it. Okay, so that's called the user study. And the third thing you can do is you could actually deploy it to your actual users. Sometimes you might do it like where half of them get the new system and the other half are on the old system, and then you try to measure things that way. So you actually integrate it in the real life, but you're also like observing what's going on, usually through software. So like it's just automatically collecting statistics and reports it back, and then you use that to make decisions about things. Okay. So we'll go through the three of them. And the expert review is the one that you'll do in assignment 2. And then we'll talk about the theory of user studies and field studies. Okay, so in an expert review, you get one person, or you could use a small number of people to do it and then see if they all agree. That's a slightly different way of doing it. But just in general, you can think of it as one person that is going to look at it and try and figure out whether it's usable or not. What do we mean by expert here? So the best kind of expert would be someone that we actually call a dual expert, which is that they're an expert in usability. So they know what to look for from a usability perspective. But we also like the expert to actually have a proper full mental model of how the thing works. Okay? So if I'm doing a usability thing of a car, I know about the usability, but I also actually know how the car works and all the different things. And then I can see things like maybe the user wants to do this, but because of this complicated reason, it will actually do something different. So you have an expertise in usability, and you have an expertise in whatever you're studying the usability of. There's different kinds of ways of doing an expert review. The one that we'll concentrate on is called a cognitive walkthrough. Basically, what you do in a cognitive walkthrough is you come up with some tasks that you think the user would want to do, and then you just do the tasks. And then you're going to do some stuff as you're doing the tasks to measure the usability of it, okay? The other kind of expert review, just for your interest, although we won't talk about it beyond this, is called heuristic evaluation. That's more like, especially, it makes more sense in software, where you open the software up and you just go through the user interface like menu item by menu item, like file, like, keynote about what does that do? What does that do? What does that do? What does that do? What does this button do? What does this button do? What does this button do? So you just sort of comprehensively go through the user interface, okay? Okay, and so the thinking, cognitive walkthrough is, I think, preferred widely because most users want to know how to complete a task. Okay, it's how we think about it. Going back to that car manual, or I use the example of software manual, but cars also come with manuals. It used to be like car manuals would be like, here's your dashboard, 1, 2, 3, 4, 5. Okay, 5 is pointing at this button. This is what this button does. They might still have some of that, but a lot of manuals now are oriented around, you have a flat tire, what do you do? Step 1, do this. Step 2, step 3. Okay, so it's more task oriented as opposed to what do these buttons, every button do. When the expert does the review, they're going to put themselves in the shoes of the user, And normally you're going to evaluate it from the perspective of a novice user, so a user who hasn't used it before, but that might not strictly be the case. You might want to evaluate it from, like, what would a developer think about this, or what would somebody who's worked at this company think of this that has a bit of expertise. So you as long as you state what kind of user you're emulating, it's fine. Normally you go with a novice user, but it might not be. Then what you do is you say, okay, what are the actual tasks that a user might want to do? And you try to sort of sort them from like the most important things that they would want to do down to like the least important things, okay? And then you'll do your evaluation starting with the most, the path, like the sort of the thing that most users would do. And then how far you get depends on sort of like your time and when you think that you should stop. Then in addition to your core tasks, you have a set of guidelines. So the guidelines tell you what you should be looking for as you're doing each step of the task, okay? So you'll just sit down, you'll start doing the task, and then you'll have a set of guidelines, and the guidelines are things to look out for. The guidelines are a set of positive things, meaning like they're things that the system should exhibit, as opposed to bad things. And they could be things like we said, the software should guide the user. So that could be a guideline. So you should say, well, at this stage, does the user really know what the next step is? Can they figure it out from just using the software? Like they've never read about it, they're not reading the manual, they're just looking at the interface, they're kind of looking at the buttons that are in front of them. Could they actually figure out what they need to do next? If there's like feedback or things like that, is it understandable? Does the user understand what's going on, or is it like full of technical jargon? Are they going to make a mistake? So every time that you'd say, well, this is a place where the user might make a mistake. And if they're going to make a mistake, is it like a recoverable mistake? Like they'll make the mistake, they'll realize it's wrong, and then the software will give them a path to correct it? Or is it the kind of mistake that once you make it, you can't, it's done, right? Like you're done, and there's no way to recover from it. So later I'll show you a concrete example of guidelines. So for your assignment, so next class I'll do a walkthrough of something called Tor, which is anonymity software. And then for your assignment, you will do a cognitive walkthrough yourself. And the guidelines, I will show you the 8 guidelines that I use next class. And those guidelines you can also use for your assignment. So in your assignment, you're not going to come up with the guidelines yourself. You'll just use the ones that are given. You will come up with the tasks yourself. Okay, so what are the pros and cons of a cognitive walkthrough? The big pro of it, it's very fast and cheap because just one person's doing it. You're not trying to pull users in. You're not trying to instrument your software to do a lot of measurements and things like that. You can cover a lot of ground in a cognitive walkthrough. The problem with it is you might miss things, okay? Or you might make mistakes. And so mistakes can go in both directions. So it might be that most likely it's that you miss things in the sense that there are usability issues and your expert doesn't pick up on them. It could be the opposite though too. It could be that your expert thinks something is a big usability problem, but it actually isn't. Once users use it, most users are able to actually use it successfully. And so you spend a lot of time fixing things that didn't necessarily need to be fixed. Okay, the next thing is a user study. So a user study is you're going to bring in actual people and make them use the software, use the tool, and you're going to try and evaluate something based on that. User studies, you want to be sure that what you are seeing is, you want to be confident in what you're seeing, okay? So like, for example, if it looks like users can use this very, very well, you want to be sure that like that's not just random chance. You just happen to pull in a couple users that are better than your average user would normally be. And the best way to tackle it is just to throw a lot of users through the study, and eventually the numbers will take care of it itself. So we'll circle back to like how many people you need, but you can think of like a lower bound as like 20. So if you use any less than 20 people, you probably can't really start saying that like what you observe is actually the truth, as opposed to like just maybe it's random chance. If you do, once you go to like 200, you're pretty confident in everything you see, and there's not much point going beyond 200. It would be expensive and use a lot of time, and so 200 would be kind of like the upper limit. Unless if you're measuring something, again, this is software. Security is important. We're not talking about like vaccines or medical drugs and things like that. Those studies are going to be a lot bigger because the stakes are a lot higher. Which isn't to imply that security doesn't always have low stakes. Sometimes it has high stakes, life-threatening stakes. But generally, for the kinds of security things that we worry about, they're important, but it's not like medical studies. Okay, so how do you do a user study? So the first step that you have to do is, before you even do the study, if you're working in a university environment, is the university has to approve every study that you do. So anytime you go out and interface with actual users, you have to submit to the university a plan for what you're going to do, and the university will review it. It's called ethics. So if you want to do a usability study for your final project, that's a great topic, but you can't do it because you would have to get ethics. And usually at Concordia, I think it takes a couple months to get approved, and so you don't have time to do it. So any study with human participants requires ethics. Even if you're not, you might still require it, but anyways, it's and this only shows up usually in academic settings. So if you work at a company, some companies might have internal ethics. Like if it's a big company, Google, Facebook, that kind of thing, they might have an ethics board. But generally in companies, you can do whatever you want. What you would do in the thing that you would submit to the ethics board is just like, this is what the study's about. This is exactly what I'm going to do. And usually if like you're just doing security stuff, like use the security software, can you use it or not? There's no like big dilemma in terms of ethics, okay? But there are a few things where there are some aspects that you would have to think a bit about. So there's three of them. The first one is normally when you bring a user in and you're going to get them to use some security software, you're not going to tell them what the true nature of what your study is about. Okay? If you tell them, hey, this is a study about how secure you're going to behave, they're all going to be on their best behavior and behave as securely as possible. Okay? So usually you disguise your study in terms of something else. You say, hey, we have this game. We just want to see whether this is a fun game. By the way, you have to create an account and a password, and then you can play the game. And that's actually what you care about. You care about, like, are they going to choose a good password or not? Okay? But from the user's perspective, they think it's just about the game. And now, because they're not thinking about security, that you'll get a more natural kind of response when they set their password. Okay? That's called deception. You're deceiving the user about the true nature of the study. You have to report that to ethics. And there's usually procedures like, after the study's done, you have to say, okay, you know what, like, the real nature of the study was actually about your password. It had nothing to do with the game. So that's the standard response, is that you just disclose what the deception is. You can deceive the user, you can use deception, but you have to disclose it at the end of the study. That's standard procedure, but different ethics boards might feel different. It depends on exactly what you're doing. Another thing, specifically in the case of passwords, you couldn't do that experiment that I described because users you couldn't do it and actually collect their password, okay? Because you don't know whether the user is going to use a password that they're using on another website, okay? So most people would say you can't do that experiment because you might end up with a bunch of real users' passwords for other stuff, and there's ethical issues with you collecting that data. And then the third thing is that you usually take a lot of demographic information, like how old are they, what's their educational background, whatever. And you have to store that somewhere, and that is private information, and you want to make sure that it doesn't leak to the public. You have to think about who, like if it's in a security lab, you might have 3 or 4 people working on it. Who gets to see that information, who doesn't? How long are you going to keep it around for? When you delete it, how are you going to delete it? How are you going to make sure it's actually deleted? So there's a bunch of procedural issues around those things. So these are the kinds of issues that you would encounter. So the board will review it. They'll either say it looks good, you go ahead, or they'll say, we don't like these aspects of it, you need to refine these aspects, and then you go back to the board and you kind of go back and forth. Or I guess in an extreme example, they might say you can't ever do that. But again, that probably is not going to show up in the context of just like security software and things like that. Okay, the next thing you want to do is you have to get some users for your study. So how are you going to do it? Well, you can put up like, I don't know, posters. You probably maybe even seen them around campus recruiting, or you get emails or things like that recruiting users. And universities that do this a lot would often have a list of people that they've used in the past. If you can do the study online, so you have to think about, do I actually need to bring the user in person? If you do, then that's one set of user, like they would have to have access to Montreal, like probably live in Montreal or at least be able to come in to the campus. But if you could do the whole thing online, like they're just using the software, so you can just tell them to fire it up and then do it, then you can use online platforms. So there's Mechanical Turk and other platforms like that where there's a lot of users, and users on these platforms are used to doing these studies. They're used so much that there's academic papers written about like who are these users that use these platforms? What are their demographics? What do they look like? And so you can sort of get a sense of who they are. And then if your users are a little different, you can maybe make some adjustments. Okay, so now you have a set of users. Also, where you advertise will also influence who you get. It's sort of obvious, but if you advertise it in a university campus, put posters on the wall, you're going to get a bunch of students, right? Now that might be okay. Maybe your target audience for your software is students, right? But like say you're making software that's not for students. Maybe you're making software for elderly people, and now you have a user study with a bunch of results of students who usually aren't elderly, right? Then that might create issues, okay? So you have to think a little bit about how are you going to try and pull in the kind of users that you actually want. Okay, so now you have a set of users. Usually the study's done in 2 steps. So you don't just bring them in right away. Usually you do a sort of vetting process first, and then you'll bring them in for the study second. So the vetting process would be have them fill out a questionnaire. You'll get basic demographic information. So like how old are they? What's their educational level? What's their income level? What expertise do they have in technical things? These are questions that would typically be asked. And then you might decide, well, I'm developing software for people that have this demographic. The users that have agreed to do my user study have this other demographic, and they're slightly different, okay? So I'm going to drop people from my user study because I have enough users of that type, but I need users of a different type. And so anyway, so you'll do a sort of filtering. You'll try and make your target demographic and your actual user study demographics, you'll try and make them the same. Now, sometimes you can't get them exactly the same. So you can also use statistical techniques. You can say, you know what, I couldn't get a lot of people that had a particular expertise, but that's important for my user study because a lot of my users have that expertise. So I could only find one person that has it, but 10% of my users have that expertise, right? So then what I might do is I might say, okay, I'm going to do the study with this person, but later when I'm tallying everything up, I'm going to be like, that person counts as if they were 10 people, because that would make them more representative in the whole study. So statistical weighting might be used if you can't actually get your participants to look like what you want them to look like. Okay, the next thing you need to do, and you basically should do this before you actually bring them into the study, is pay them. Okay, so this isn't free work. People aren't volunteers. They are being compensated for what they do. It's a payment for the time that they spend. Usually it's a set amount. Like you do this user study, it's $10. It will take you 20 minutes and that's it. Sometimes university groups might not have enough money to pay everyone $20. So they might do like a raffle, like we have 2 iPads to give away, and all the people who participate will put your name in the raffle for the iPad. So that those are usually the 2 payment structures. And the important thing is about payment, the reason I put it before the user study is you're naturally going to think, I should pay them when they finish the study. What if they get up in the middle and they leave, right? Then I wasted my time, and so I'm going to not pay them until the very end. Well, what will happen is that person who wanted to leave in the middle, right? They might do what you think you want them to do, which is they'll actually finish the study because they just want to get paid. Okay? The problem is for that second half, when they've sort of given up, is they're not going to try. They're just going to sit there, they're going to do the bare minimum just to get paid. Okay? So you would actually rather that they get up and leave, because then they're not going to bias your results. Okay? So what you do is you pay them at the start. It's not contingent on finishing the study. They can get up and leave at any time. You can pay them and they can just get up and leave, and you're just like, that's fine. I would rather you do that. Like, if you're just here for the money, that's fine. I don't want you to influence the data or bias it in some direction. Okay? So that's pretty standard procedure. And even though you could think that people would like treat this like a scam, they don't, right? Like, most people will come in and they're going to try and usually to get to the stage where you're actually going to be in a study, you had to do the pre-study questionnaire, and you had to like respond to the recruitment message and things like that. So most people aren't going to put all that effort in just for $10 at the end. Okay, so now finally you're ready to do the actual study. So studies need to be carefully designed. Every detail you need to think about. What you're going to do is you're going to bring the user in and you're going to tell them what you want them to do. And it's best to actually write down exactly what you're going to say to the user and read it off the page. Why? So the answer is, well, let's say the first user comes in and I'm the person running the study. I'm really excited. We're finally getting the study done. I'm very patient. I'm going to explain every detail. I'm going to try and simplify it. Okay? Then 2 weeks go by and I've run 20 users through this study. I'm tired. I'm not patient anymore. I just want it to be over with. The 20th user comes in and I have to give them instructions. I'm going to give them like the bare minimum instructions. Okay? So user 20 is going to perform perhaps worse because my instructions weren't as good as user 1. Okay? Those are the kind of biases you don't want to have in your user study. So the easiest thing is just make sure everything is exactly the same. Every user is treated exactly the same if you can control that. Okay, so write down everything you're going to say, and when you say it to them, read it off the page. Now, obviously, users might ask you questions, right? And so because this user asked this question, I said something to them that I didn't say to other users. That's fine. That you can't control for that. But anyways, everything that you can control for, you do control for. Usually, you don't go do a full-blown user study right away. Usually you'll try it with 2 or 3 users. You'll see how it goes. You'll refine it, and then you'll try it with another couple users. And then when you're really, really confident in the user study, then you might try it with like a larger set of users. Okay, now there's 2 ways of doing usability studies. One of them is, so I have something, we'll just call it thing. It could be software, hardware, whatever. We'll call it X. So we'll call it A. That's better. I have A. I want to know whether A is usable or not. Okay? The first thing I could do is I could try to measure that directly. Okay? It's hard to do because when is something usable or not usable? Okay? Sometimes you have like clear criteria, like the user can actually complete this task. They can get all the way to the end, or they can do this task in less than 2 minutes or whatever. Sometimes you have like clear like criteria for what it means to be usable, but sometimes usable is just sort of a vague kind of thing. So an easier user study to do is you say, I have my system A, and there's this other system that's pretty close to A. Call it B. It's from a competitor, or it's the old version of A. I have a new version of A, and here's the old version of A that people have been using. Whatever it is, we'll call that B. Okay? And what I'm going to do is I'm just going to try and measure whether A is more usable than B. Okay? That's a lot easier to do than try to establish whether A is usable. Okay? Because then it's a comparative study and everything you can do is just comparative. We're not saying it's usable or it's not usable, we're just saying it's more usable than B. Okay? So that's usually what most user studies do. So they will try to compare two systems. So you always try and find something to compare yourself to. And at the end of the day, you learn whether you're improving the security or not. Or sorry, the usability or not, rather than like some sort of universal truth about whether it's usable or not. Now, let's say that you want to run a user study and you want to compare A and B. How do you actually do it? Okay, so you bring a user in and you say, okay, I want you to do task. I have this task for you. Here's system A, do it. And then you measure all the things that you want. And then you say, okay, now we have this other system B, and do that task on system B, and then I'm going to measure all the things. Okay? Is there any problem with that kind of study that you can think of? Okay, what if the user is a bit better at using system B because they use system A? They use system A once, so they at least have done that task on software before, so they know a little bit more about that than they did walking into the study. And so they might use B better just because they kind of learned things from A. Okay? So how would you fix that problem? And what if, like, across your study, everyone does A, then B? Then the next user does A and then does B, and then you're like, oh, B's better than A, right? But it might not actually be better than A. Okay, so
different subjects.
Okay. So two answers. One is you can randomize it. So some you do A before B, you could do B before A. So randomization is something you should use to any decision that can be randomized should be randomized. A more extreme example, which is actually better, is when you bring your user in, you don't even make them use A and B. What you do is you split your user group in half. Half of them use A and they never see B, and the other half use B and they never see A. Okay? In that case, there is zero cross-contamination. The problem with it is you need kind of like twice as many users because half of them are only using one system rather than the other. Okay? So that we call between subjects, where half use A and half use B. And it's considered the best thing to do. The next best would be to randomize between A and B. And the bias of if you use system A, you're going to be a little bit better at system B. We call it learnability because you learn something from using A as opposed to B. So that's learnability bias. So you can split participants in two groups. First group will use A and never see B, and vice versa. Another thing you should do is now you have a problem of how do I put users into two groups? Okay, what if all the good users, the expert users end up in group A and all the novice users end up in group B, then A is going to look better than B even though it might not be. It's just because that's how the assignment happened to happen. Okay, so this is where, again, you can use randomness. Okay, so you can randomly assign. The more users you have, this kind of bias will disappear. Okay? If you're running a study with 4 users, right? This is a bias that's going to show up, right? Like there's a really good chance, there's a 50-50 chance that like your 2 best users end up in the same group as opposed to in different groups, right? But if you have 200 users and you're putting 100 in group A and 100 in group B, yeah, like it might be like 51 or like, sorry, yeah, anyways, there might be 1 or 2 more experts in one group than the other, but because you have hundreds of people, it becomes very small. Okay? The other thing you can do is you can go back to your questionnaire and you can look at the demographics and you can just do a quick sanity check that the groups look kind of the same in terms of demographics, and you could do adjustments based on that. But random assignment with enough users is the best way of getting rid of it. Okay, so you do your user study, you measure a bunch of stuff, right? You have all your data, and you want to do something with the data. Okay, so during the study, you're going to be collecting data. So you might be measuring things. The software that they're using might automatically collect it. You might be timing things. There's all sorts of different things you should do. And the data that you're collecting is of one of two forms. So the first is it can be quantitative, which means it's a number. How long did it take the user to do task A? Well, it took this user 30 seconds, this one 27 seconds, this 42. That's a number. We can do averages. If I have a number for group A and a number for group B, I can compare those numbers and say which one's bigger and which one's smaller, okay? Working with numbers is easy, okay? But sometimes the things aren't easily captured in numbers. Like, did you like using the system? Was it hard to use? Did you have problems, right? What was the trickiest part of using the system? So the user will give you an answer. The answer is useful to you, right? And you can't ask an alternative question that would make their answer a number. So you have no choice but to ask these sort of answers that you get back in words, right? So we call this qualitative information. So it's answers that you get back in words as opposed to numbers, okay? All right. But ultimately, so these are just examples. So quantitative would be like, yeah, I completed users completed the task 7 seconds faster on system B. Users' errors decreased from 18% to 4% with system B. And then qualitative would be like users liked system A better than using system B. Now, let's say that you really, really like numbers, okay? You would rather work with numbers. They're a lot cleaner. It's easier to prove things and show things with numbers. But at the same time, you do want to measure a bunch of qualitative stuff, like whether users like a system better than another system. Is there any way we could convert that qualitative information into quantitative information? Okay, so it's something you've all used before. You've probably got a million emails, or like Concordia's probably asked you to fill these things out. And so yeah, it's a scale. There's even a name for it. So it's like this kind of thing, right? I'm sure everyone recognizes it. This website has a user interface: strongly agree, neutral, disagree, strongly disagree, okay? Why have we all seen this so much? Because it takes qualitative information and turns it into a number. Now I have a number between 1 and 5, or a number between 1 and 7. I can compute averages. I can say, the average answer on system A is higher than on B, and it's by this much, and things like that. Okay, so these are called Likert scales. And you'll see them a lot, and you'll use them a lot if you do usability work, because a lot of the information you want, you can extract in qualitative form, but you ultimately want to turn it into a number. So this is like a standard thing that is used a lot. Okay, so what are the problems with these kinds of scales? I wanted to ask it before I showed you the answer, but now it's there.
It's hard to gauge what strongly agree means.
Okay, so there might be some uncertainty about the user, like when does an agree become a strongly agree or a weakly agree? This is the kind of thing that would probably both groups A and group B would struggle the same with. And so it probably wouldn't be something that would bias it in favor of group A or group B, but it would be something that users would annoy users for sure. Anything else? Okay, how much do you think about the first question that you're asked compared to how much thought you put into the 30th question that you're asked on one of these surveys, right? You're going to spend a lot of time thinking about the first one because you're fresh, it's interesting, and by the time you get to the 30th, you just don't care anymore, okay? Now, what's the ultimate expression of I don't care? It's I agree, or strongly agree, or strongly disagree all the way down, okay? So these are the kinds of things that you need to contend with, okay? We don't want users to get bored. We want them to understand what they're doing. We don't want just to get like a response just to complete the survey so I get paid. Okay, can we do anything about either of these? What about the user fatigue? What could I do to make it so that the 30th question isn't like poorly answered relative to the first question? Okay, so one thing is to simplify the survey. Okay, less questions, better. Try not to fatigue the user. Instead of having 7 things, you could have 3 things, that type of thing. So simpler surveys, you're going to get a better response. Let's say you have no choice, you have 30 questions, and you know for a fact that users are going to get tired after 20. But you got to do it anyways.
For example,
Go ahead, William.
No open-ended questions.
Okay, so that's true. So we're already doing that for the Lacquered scale. We're forcing them to choose this.
You could just split the amount of questions between the different users. Like 10 questions are answered by certain users, 10 by some other users, and 10 by
Okay. So you could give users a subset of the questions, and then you could do it. So that's interesting. So that would be approach.
we can also set a rule for each question. For example, there is 20 seconds of time.
Okay, so you could use some sort of timer or something like that.
Maybe we can change the type of answers, like rather than putting like strongly agree, disagree, change the type like yes or no, no. And
Okay.
change the type so that,
So that sort of goes with simplifying, try and reduce the fatigue.
Increasing the number of users taking the survey, for example, instead of 20%, just asking from 50%, and then randomizing the question numbers to see which one is actual answers and others.
Okay. So you could increase users, always a good thing. But sometimes for practical reasons, it's too expensive and it's too much time because you have to spend an hour with users. But the second answer is what I was looking for. What if the first question that I see is, or say the 30th question that I see isn't the 30th question that you see? For some of you, that's the first question that you see. Then it's going to be fresh for you. So what's stale for me is fresh for you and vice versa, okay? So the easiest trick is just randomize the questions. Everyone gets a different order. For some people, some questions, or later when you're looking at the data, you'll know that this particular question was seen early for some of your users. It was seen late for some of your users. And those fatigue differences will kind of average out. Okay, what about the second one? I disagree. Someone's just going to click I disagree all the way down because they just want to get over.
you could create sort of multiple choice questions and just change the options, keep it random, so like people don't just.
Okay, so you could randomize something about the order or something like that. But when I say click I disagree, I don't mean the user is going to look and find the I disagree. What I mean is they're just going to choose the right column. And if the options are changing, then the options are changing.
You have to put questions all in the same way. For example, the disagree answer for one of them is positive answer and for the other is negative answer.
Okay, great. So that's exactly right. So you do 2 things. The first thing you do is you ask the same question more than once. Okay, so normally when you're designing one of these things and you're worried about user fatigue, you'd be like, why would I ever ask the same question twice? But you see it. If you've taken these surveys, if you haven't, you'll start noticing it now that I've told you. But you'll be like, I thought I answered that already. It's not literally the same question. It's just worded a little different. What they're doing is they're doing a consistency check. So when you answer the question the first time and you say, I agree, as opposed to strongly agree, and the second time they give you more or less the same answer, just phrased differently, they want to see that you also check, I agree, right? If you say, I disagree to the one and I agree to the other, that's inconsistent, okay? Then the fanciest thing you can do is you can actually flip the question around. I like system A better than system B, I strongly agree. And then later you're like, I like system B better than A, right? If I strongly agree with the first one, then I need to strongly disagree with the second one. So if I'm just choosing strongly agree all the way down, then it will force an inconsistency. Okay? So notice this next time you take these surveys. Notice that they often will ask the same question more than once, and sometimes they'll flip it around so that the consistent response would be I agree on one version of the question, and it would be I disagree on the other one.
ironic because looking for that consistency, fatigue also.
Yeah, agreed. Yeah, you're adding more to deal with fatigue, but yeah. Yeah.
Something like convert qualitative to the quantitative. If there are much more questions, won't the user be tired of the answers?
Exactly, yeah. So that's sort of the irony of this whole thing. So these consistency checks are adding questions. They're making your questionnaire longer. As a result of making it longer, users are going to be even more fatigued, right? But no one has a good solution, so that's what the solution is. So then you just randomize the questions and let users get fatigued. Yeah? Okay. So the ideas here are to simplify the survey. I said shorten, but you can think of it as simplify in any dimension. Less questions, easier scale. Randomize the order of questions, and then you can do these consistency checks where you ask the same question more than once, sometimes flipped around, positive versus negative. Okay, so now we've done our analysis. We have some quantitative data like time it takes to complete a task. We have our qualitative data, which we've churned into Likert scale, so it's now a bunch of numbers. And now we want to say something about it. Okay, we want to say that system A is more usable than system B. What does that look like? What does that statement actually look like? So here's where you would apply some statistics. And I'm not going to go through that. The purpose of this class is just to get you familiar with the nature of the studies and what you do. Sometimes these things are complicated, especially if you're doing weighting between your different groups. And so it's not like high school level math statistics. Usually these people are experts. They might have a PhD in like doing this kind of stuff. And I personally wouldn't do the statistics for one of these studies because I wouldn't know enough about it. So it's usually sort of slightly complicated. But this is sort of the flavor of what they do. So they say, write down a hypothesis. So a hypothesis is something you want to test. And you don't have to write it down in the way that you think it's true. You just have to write it down in a concrete way. Whether it's true or not doesn't matter. So you might say, system A is more usable than system B. That's my hypothesis. That's what I'm trying to measure. And maybe I actually want B to be more usable than A. That's fine. Then I'll disprove that hypothesis, which is what I want. So the phrasing of it doesn't really matter. Okay. So the statistics are going to measure two things for you. One is the hypothesis true or not? Okay, so it might say it's true. It might say it's definitely not true. It's definitely true. It's definitely not true. It's definitely been disproven. Maybe it's sort of in the middle. Okay, what does in the middle mean? Well, in the middle means that maybe you're seeing, like maybe A is slightly more usable than B according to the numbers, okay? But that's within the margin of error that I could expect by randomly assigning people to two groups, okay? Because I did that random assignment, it is true that maybe some people who prefer A to B ended up together in the one group as opposed to the other group. And so maybe what I'm observing is just random chance. Maybe if I reran the study with 20 new people, I would see the opposite thing. Or maybe I would continue to see it. Okay, if I continue to see it, then that's sort of the truth. And if it disappears when I rerun it with different people, then it was just an illusion of randomness. Okay, so what you want to do is you want to measure both of those things. Is the needle like toward it being true or toward it being false? And is the needle far enough towards it being true that you actually think it's actually true as opposed to just random chance? Okay, so the hypothesis looks true, and it's more likely true than random chance. The hypothesis looks false, and it is actually more likely to be false than to just show up by randomness. Or it might look true or false, but it could be, it's within the margin of error. It could be just random chance. So these are sort of like the three outcomes that you would have. Okay, and if you achieve one of the first two outcomes, then we say that your result, either the hypothesis is true or it's not true, is statistically significant, is the term that's used. So you would see that at the end of studies. And sometimes studies will report, even if they get something in the third category, they might still report it. They'll say, well, we couldn't get statistical significance on this, but, it did look more true than false. So, we're just throwing it out there. Maybe some follow-up studies could run some more numbers and we can try and figure out whether it's significant or not. How many participants you use will have an impact on how easy it is for you to get significance. The more users you use, the less influence randomness has on the numbers. The less users you use, the more impact randomness can have on your numbers, okay? So very roughly speaking, if you have 20 participants, you will be able to get statistical significance, but the result needs to be like pretty large. Like people have to really prefer A to B, and it needs to be a strong kind of signal. Then with 20 users, you could establish it, and you could establish it with significance. If it's some smaller effect, like people actually prefer A to B, but it's subtle, right? Then you might need up to like something like 200 participants for that to get significance.
Before you said that the less participants that we have, because we want to like divide them in two groups for two systems. So, for example, system A could be shown as more efficient.
Yeah.
Because the people are more familiar with that system. So how can we solve this problem?
Okay. So you're actually saying a couple problems. So let me go through each of them one by one. So the first thing is when I say 20 participants, if I have two groups, remember that means 10 in group A and 10 in group B. So I really only have 10 on each. And another thing is like that I didn't outline here, but let's say I'm doing a comparison between 3 systems and I have 20 participants. Now I only have 7 in each group, right? And if I have 4 systems, I have even less. Yeah, I have 5 users, right? So the more options you have, the less users you have in group, then the significance is also going to kind of disappear. So you do have to remember that you are splitting people up when you think about what these numbers are. And then your second question is, if people are familiar with A and they've never used B, like how do you
It could be shown that, for example, system A is more efficient.
yeah.
Because people just prefer.
That's correct. So what you need to do in that case is you would have to try and control that in your pre-study questionnaire. So you basically have to go out and try and find people who've never used System A. And you could only do your study on people like that, yeah. Okay, other questions? Yeah.
So essentially for any usability study, the main bottleneck would become the participant, right?
Correct, yeah.
But then what if instead of having participants, and one more question I had
Yeah.
actually was, if the hypothesis, in case it's like the third option we get, then we would have to either ways conduct another study, right? So would you say it is more efficient to conduct more studies like than a single one to have a better result?
Yeah, so what you would do normally is you would run a bunch of participants through, and if you end up in the third category, you can just run more participants.
And follow up to that.
Yeah.
So in this case, the humans become the bottleneck more or less, right? So what if instead of using like humans, you could just replace it with an AI?
Yeah.
Just have it do all the usability study, just put whatever requirements you have, and then use that data to get a more statistical significance, because you will have more data as well, right? In that case.
Right. So an AI would be like, it would be like the equivalent of one participant. Even though it could pretend to be 100 people, those 100 people would all use the system effectively the same because it's all coming from the same model. So it wouldn't actually add, like in statistics, what we look at is independent variables. So like things, people that are independent from each other, like they're unique. And so that's why you couldn't boost the numbers just with using AI. And then there's the whole, like, does the AI actually behave like normal users and things like that. It's something you could do definitely like in a pilot. So like in the early stages, you could just play around with an AI being the user and tell it like invent 20 different personas or whatever. And it might be something that helps you refine the study, but you wouldn't want to use it in the actual study itself. Okay, yeah, so statistical analysis. So these are just rough numbers, like you have to actually run the numbers with a proper statistical person. But this is what I see, a summary of what I see in the literature in terms of numbers. Okay, so quickly, the pros are you get to test it with normal people as opposed to the expert review. You actually have a normal user as opposed to someone pretending to be a normal user. And then the cons of it are your normal people might not be exactly the users of your system. They might look different. There are a bunch of university students where you need something else. These user studies, you can't bring someone in and make them use the system for 8 hours. It just doesn't work, okay? So user studies are usually 30 minutes, maybe 60 at the most. And because you're asking questions and you're measuring things, you're usually kind of going through things slowly. So the amount of coverage you can give to the system in a user study is very limited. You have a small window where you can measure whatever tasks a user in this setting could complete within 30 minutes. It's not going to necessarily be a lot, okay? So the coverage is low. So usually you would use this to zero in on a couple areas that you're like particularly concerned about. When you bring people into the lab, it's a different environment. They're not sitting at home, right? They came in the university, there's someone there, they have a clipboard, they're watching everything they do. Are they going to behave exactly as they would behave at home? Not necessarily, okay? So we call that the ecological validity. So ecological meaning like the environment in which you're doing the task. So the way I behave when I'm in a lab and someone's looking over my shoulder and the way I might do it at home if I was just on my computer could be two different things, okay? So a user study is not great at trying to eliminate problems or biases due to the ecological concerns. User studies are expensive, so you have to pay every user. And then the most important thing is they're time consuming. So at least one person has to sit with the user and do the study with them. And so if you're going to run 20 users, usually you can't necessarily even book them back like end to end. But anyways, you're going to spend a week like just doing this user study over and over again, and it's a lot of time for like someone to do. And then the final issue is that because you're measuring for such a small amount of time, the way a user responds the first time they see something could be different than the way they might respond after seeing the same thing for the 20th time or the 100th time or the 200th time. So at the end of the user study, you know how users like it the first time they see it, but you don't really know how much they're going to like it the 20th or 100th time because you didn't get to see them use it 100 times. Okay? So I'll tell you a little story about that issue, but before we do, why don't we take a break? So come back in 10 minutes, and I even have a video, so I'll try and get the audio working. All right, so I have a video, just a fun thing. I can't seem to find, most classrooms have like a audio cable, so you don't even really need to hear the sound, but I'll play the video and then we'll talk about why I'm even showing it to you in the first place. So it's just a kind of commercial. You can see this Pepsi challenge thing. I'll play it a couple times so you can see what's going on. But essentially there's, lots of people dancing and because they love Pepsi. But the Pepsi challenge part of it, you can see, let me play it and then I'll play it again. Okay, so there's this thing that says take the Pepsi challenge. They're drinking Pepsi. You can see that there's a sort of thing that's blocking it. There's a can of Coke and there's a can of Pepsi. And then when they reveal it, they open it up and they show which one's which. Okay, so what's happening here is this was something that actually happened, a historical thing. What Pepsi decided to do is their competitor is Coca-Cola. And so what they decided to do is actually go into grocery stores and they would do this sort of Pepsi challenge where they would give people Coke and Pepsi in a cup, but they wouldn't tell them which one's which. Okay? It would be behind the shield. And then they would have the person drink it. And then whichever one they liked better, they would open it and show them whether they chose Coke or whether they chose Pepsi. Yeah.
Is this an official advertisement?
Is it an official which?
Advertisement or?
Yeah, so this was something that not only made it into their commercials, but like the chances of you going to a grocery store and Pepsi actually being there were pretty high. So they actually went to like real grocery stores and they did it a lot. It was like a huge marketing
But
campaign.
I'm wondering that if they were allowed to use Coke in their advertisement videos or it's not an official thing.
If they were allowed to use, sorry, I didn't catch the word.
Because of the copyright.
Oh, I see. I think, anyways, they did measure it against Coke. It does seem like it says Coca-Cola, but they might have had to blur it out. It's such a grainy video anyways, I can't tell. But normally, in terms of copyright, you can use competitors' copyrights if you apply fair use. Like, so there's a bunch of rules. Copyright gets kind of complicated. It's actually trademark in this case as opposed to copyright. But anyways, I don't know whether they were able to do it or not. But the implication definitely was that this was Coke. Okay? All right, so Pepsi did this. Why would Pepsi do this? Okay, so you could go in there, you could drink both of them and say, I like Coke better, and then they open it up and it's like, oh, you chose Coke. And then you go home with a can of Coke or a case of Coke, right? So why is Pepsi actually doing this?
To understand like the preference of taste for people.
Okay. So they might actually truly be curious. Do people like Coke or Pepsi better? But in that case, they could do it behind closed doors. In fact, they probably do it all the time. They probably have like a dedicated team that just does this all the time, right? Why go into grocery stores and do it in front of people? So for science, maybe. Okay, so it does grab attention, but in this case, I guess you do know it's Pepsi that's there. So even if you choose Coke, you are exposed to Pepsi. Okay.
Sure that the products are the same or similar, and the difference between them is marginally small. Just a brain thing that tells you that this is
Okay, so it could be, this is interesting, it's not what happened, but it could be that Pepsi's like, everyone buys Coke, and we just want to show we're equal to Coke. Okay, so that's a good strategy, but Pepsi actually were more confident in themselves than that. The reason they did this is because they would win. Okay, they would go in and people, not 100%, but way more than 50% of people are going to choose Pepsi over Coke. Okay, and so Coke was actually getting slaughtered because of this whole marketing campaign, and their numbers were going way down because for some reason, when Pepsi did this, Pepsi somehow figured out they could do this, and people actually like Pepsi better. Okay, why do you think they like Pepsi better? You probably all drank both. Is there any actual difference? Do they taste exactly the same?
Pepsi is a bit more fruity than Coke.
Okay, so the flavor is slightly different. The way I would describe it is sweeter. So Pepsi's a bit sweeter. The sugar content's a little higher. At least back in these days, I don't know what it tastes like today. But Pepsi's a bit sweeter. And so that's probably what people were picking up on, just the sweetness. Okay, but this was like a massive problem. Okay, like to the extent that Coke felt like they had to do something drastic. So what would you do if you were in Coke's place? If Pepsi's beating you because it's sweeter, what would you do with Coke?
I would make it sweeter.
Okay, you make it sweeter still. Okay, so what Coke said is they said, okay, we're going to go and we're going to engineer a new drink, right? We're going to replace Coca-Cola with a new flavor of Coca-Cola, and we're going to engineer it specifically to beat Pepsi in this challenge. Okay, so what they did is they came out with, I've been alternating between Coke and Coca-Cola. So Coca-Cola is like the original classic drink. And they went to the lab and they came out with this, which is they just called Coke as opposed to Coca-Cola. But it wasn't like you could go in the store now and buy either Coca-Cola or Coke. This was a replacement for Coca-Cola. Okay, so this was a re-engineered drink. It replaced Coca-Cola. You couldn't get the original Coca-Cola anymore. You could only get this new Coke. Okay, the new Coke was sweeter than the original Coke and sweeter than Pepsi, and it had a citrusy kind of fruit flavor to it as well. So those were the two significant things. All right. So then Coke was like, okay, we're going to beat Pepsi at their own game. And so they started doing what Pepsi was doing. They would go into grocery stores, they would do the blind taste tests, and sure enough, people were choosing new Coke over Pepsi. Okay. So Coke wins in the end, right? All right. So there's one problem, and this is why I'm telling you the story. It has something to do with usability. Coke was winning. They were winning the Coke Pepsi challenge now. Okay, but there was one problem. The problem is that someone would go in the grocery store, they would taste the two, they'd say, yeah, this new Coke is better. They would go home with a case of the new Coke. Okay, then they would drink a can of it, or two, or three, and all of a sudden, all the things that make Coke taste better than Pepsi when you have a sip of it, like it's sweeter, has this fruity flavor, you don't really like so much when you've drank a whole can of it. Okay, it's good on the first sip, but then, you're half a can in and you realize, oh, this is actually kind of gross. It kind of tastes like syrup, like medicine or something like that. Like it's not actually that good of a drink. Okay, and this was actually Coke's advantage all along. Even though it wasn't as sweet as Pepsi, it's sort of more drinkable in larger volumes than Pepsi because of that lack of sweetness. Okay, so new Coke flopped. It did well on these tests, but then within a couple months, I don't know the exact time frame, no one bought it. It was considered a disaster. Coke had to actually then remove it from the markets, go back to the original Coca-Cola, and then today, as you know, that's what we have today. Okay, so this is, if you want to read more about this whole thing, it's from this book, Blink, by Malcolm Gladwell, which is a very popular book that you may have heard of. So there's other examples of this kind of thing. So the big, I guess maybe the lesson of this is if you take a sip of something, right, that's fine, the first sip that you take, but your reaction to it later could be different, okay? And in a user study, what you're doing is you're giving the user their first sip of something, okay? So things that do well in a user study might not do so well once the users actually use that system for a week or a month. So another example of this was in Microsoft Word, they had this like Clippy thing. And Clippy was this like little icon that would appear and it would give you like prompts to do stuff. Like, oh, it looks like you're writing a letter. Do you want help with it? And it would kind of dance around and it was like actually really annoying, right? But you could see why this would do good in a user study. You're in a user study, you sit down a user who has never used a word processor before. They just want, and you say, write a letter. And this thing jumps up and says, hey, it looks like you're trying to write a letter. Do you want me to help you? And you're like, yeah, sure, I'll take the help. And then you use it. And then it actually does give you a template or whatever for a letter. And so you're like, wow, that's great. And the usability like would be off the roof probably because users are using it for the first time and it's actually helping them. Okay. Then the user gets the software, they install it, and now they're using Word 6 months later. What do they think about the like little paperclip that's dancing around when they're just trying to write their letter, right? They don't like it anymore, right? And so everyone makes fun of this, and there's lots of memes and stuff. Even today, it's part of internet culture, even though most of you, does anyone remember actually seeing this in Word? Yeah, okay. So eventually in 5 years when I give this example, or 10 years, people will be like, I don't know what that is. But yeah, so anyway, so it's another example of like sips of things are different than what you would expect over the long term. And so this is the problem with the user study is that if there's fatigue with something, but it's only going to show up after a month, or habituation, you get used to how something works after a month, you're not going to be able to measure that in a user study because you're only getting that first interaction between the user and the thing that you're measuring. Okay, so the final thing that you can do is called a field study. And so a field study, what you're going to do is you're going to test usability by actually deploying the system. And you'll deploy it, you'll give it to your actual users, and because you want to collect how they're using it, you'll usually instrument it to collect some statistics or things like that. You might do questionnaires and those types of things in and around actually having them use it. So an example from people in Ottawa and in Montreal, I really like this study, just an academic paper. What they did is they said, we want to like understand how people get malware in the first place. And then how do they react to it? What do they do? Do they notice it? Like, how do they try to remove it? You know, we want to understand all of that. So we can bring people into a user study. We can have them sit down at a computer. We can give them a virus and see what happens. You know, there's all these like different user studies that you can do, but it's really hard to like kind of replicate that. Like, how did they pick up malware in the first place? So what they decided was the field study approach is they just gave people laptops. They said, here's a laptop, it's yours. There's some special software on it that's going to monitor some of the stuff you're going to do. We have all the ethics and the privacy worked out, so we're not like collecting all sorts of stuff. You can sort of see the kinds of things that we're collecting. And they just sat back and waited to see if anyone got malware. Okay? And sure enough, a couple of their users, you know, whatever they did, they got malware. And then now we know, we can understand like what went into that and how did the user react and all that type of stuff. And that's like really real data, because this person is using their laptop at home. By the time this comes around, they've probably even forgotten that it's a university computer that's collecting data. They're literally using it the way that they would use it because it is their computer. Okay? So you replicate by actually giving the user study to the users to use, you're replicating the way that they're actually ultimately going to use the software. So again, what you tend to do is you tend to not give all users the same system. What you do is a test where you would give half of the users the new system, and then the other half you wouldn't, and then you would be measuring differences between them. So sometimes I didn't use this jargon before, but we sometimes, in field studies in particular, I don't know why, in user studies we call it between subjects. For websites, we tend to call it A/B testing. It's the same concept. But anyways, A/B testing is just that half the users see A, half the users say B. It's a random assignment, whether you're in group A or you're in group B, and then we measure the differences between them. It's used a lot in like web design. And in fact, like, for example, let's say that you want to advertise on Google, so you buy AdWords. They'll say, do you want to do A/B testing? And you'll be like, yeah, I do. And they'll say, okay, word your ad one way, and then give an alternative wording. And we're going to randomly show users either wording A or wording B. And you can check back in a week, and we'll tell you how many people clicked when it was wording A and how many it was wording B. And then you realize, oh, there's something about B that's better than A. More people are clicking on it. So then you might do the experiment again. You might take B and then try and modify it again. And you would try to like narrow in, right? So like here's an example where these websites are exactly the same, but the Learn More button here is blue. Here it's green, and it has that little arrow, and 72% of people are clicking on it when it's green, and 52% are clicking on it when it's blue. Okay, so you can measure all of these types of things. Okay, so the field study, what's good about a field study is the ecological validity is strong because they're using it at home, they're doing work. If you give it to them because they work at a company, they're actually doing their work on their computer. So they're using it exactly as they would if they were actually using it, if they weren't part of the study. So the ecological validity is basically perfect. Because you're giving it to, say, your employees or your users, those are the people that you're testing the usability from. So the people that are in your study and your users are the same people, okay? Unlike a user study where you're going to give your software to your users, but you're going to run your user study with some university students, okay? They're not the same people, but here you're actually giving it to the actual users, okay? So we call that representativeness. How representative are the people in the study with your actual users? And in this case, again, it's perfect or near perfect because they actually are your users. Once you get the whole thing working, you can give it to as many people as you want. Doesn't really matter. You can give it to 10 people, you can give it to 200 people. It might depend on how many users you have or how big your organization is, but there's no real additional cost to giving it to an extra person. Another thing you can do is you can measure then for a week, a month, 3 months, 6 months. Okay, it's not like user study where you bring someone in for a half an hour. So that like Coke test, the sipping, all those problems go away because you can see how they behave after 3 months of using the system. You're not just getting their first interaction with it. Over time, your users will use every aspect of the system that is actually something that they would use. Okay, so sometimes you might have to wait a while for one person who wants to do this one thing with the software that the software is capable of doing, but is not a common task. Not a lot of people do it, right? But eventually you give it to 100 people and you wait 3 months, somebody somewhere will have done that. And so you'll be able to see the usability of the whole system. And then you can also see sometimes, like when you set up a user study, you're deciding beforehand what you're going to measure. Or you're deciding what tasks are you going to have them to do. I'm going to measure this, I'm not going to measure that. But then when users come in and they use it, sometimes they use it in ways that you don't even expect. And you're like, if I knew you were going to use it that way, I would have done my study different, kind of thing, okay? And so this also lets you see all of that kind of stuff. What are the shortcuts? If people are trying not to use it, how are they not using it? All those kinds of things you can also see. Okay, so field studies sound great. In fact, they are great. They're better than a user study. They're better than a cognitive walkthrough. Okay, they are the best in terms of what they give you. But why doesn't everyone just do field studies then? So too much money. It's expensive. You have to write the software. You have to instrument it to collect data. So you're not just writing the software, you're also writing a whole layer underneath that's going to do all the data collection for you. And if your software is bad and buggy, and you give it to half of your employees, and there's something wrong with the software, and all of a sudden they can't do their job because you're running your little pilot study, right? Then that's going to hurt the company's bottom line, right? And so you're never going to be able to do that field study again, okay? So your software has to be highly polished. It has to be perfect. It has to not get in the way. It has to be instrumented for data collection. And if you can check all those boxes, then you can do your field study, okay? Now, the other thing about usability is, I have a slide about it, but I'll say it now because it's fresh in my mind. You don't have to choose between these three. You can do all of them. Okay, and that's what most people will do, is they'll do a cognitive walkthrough first, and then they'll maybe isolate a few things that they're really concerned about, and then they might user study just those things, right? And then they'll polish it, and they'll polish it some more. They might go back to a cognitive walkthrough, do another user study or whatever, and then eventually they'll build up to the field study. And so they won't, by the time it reaches the field study state, if it ever does, they've already done user studies on it. They've already done 1 million cognitive walkthroughs on it, and so they're pretty confident in it. Another thing, unexpected task completion. I just wanted to give another sort of fun analogy. So does anyone know what this is? First off, just what does it look like is happening in this picture in terms of what I'm highlighting? Not a trick question. Sorry? Okay, it's like a sidewalk. Is it an actual sidewalk?
It's not a sidewalk. People are used to walking as a shortcut.
Okay.
Since everybody's walking daily, there's become the glasses have one or from the other.
Exactly. Okay, so there probably is some sidewalks in this picture. People don't like taking the sidewalk. The shortest way to get from here to here is to just walk over the grass. And if you have enough users that walk over the grass, then you're going to get these wear patterns, okay? And so these things are called desire paths, or there's another term, wear paths, that is like the actual technical term, okay? Now this is actually useful information. Let's say that you were the person who was tasked to put sidewalks where people might want to use them, and you go and you look at this lawn and you see this pattern, right? Where are you going to put a sidewalk? Right. If you care about your users, you will put it along that path, right? Now, maybe you don't, or you care about the lawn looking nice. You might do the opposite. You might try and put fences to stop people. But anyways, university campuses, not so much ours because we're like an urban campus, but like if you go to Loyola or like other traditional ones, there's million wear paths, right? And often you would see fences and things like trying to like protect the lawn and stop people, okay? But if you care about your users, the point is that this actually tells you information. Okay, you can look at it and you can say, this is what users want. I'm going to give them what they want. But you're not going to see that until a bunch of people walk around just going about their daily lives. Yeah.
But what users do, not want.
Exactly, yeah. Okay, that's a better way of putting it. Yeah, you can see what users actually do. They might tell you, oh, I never cut across the lawn. But wait a month, and if you see this, you know that they're lying to you, right? Okay, so in a field study, you get to see this kind of thing, the digital equivalent of it. You can see that people, you want them to do it a certain way, and they're not doing it. They're taking this shortcut. A lot of users are taking this shortcut. Then you can think twice about, well, should I just enshrine that as the correct way of doing it, right? I could make that shortcut the actual way of doing it, and then my system would be a lot more usable, okay? So anyways. Okay, and then the last thing is what I said before is that you can combine, you don't have to choose between the three of them, so you can do cognitive walkthroughs to start, then you can do some user studies, you can go back to cognitive walkthroughs, and eventually do a field study. Okay, any questions about any of those things? Okay, so next class, what we're going to do is we're going to go back to the cognitive walkthrough. I'm going to do one for you, just for fun. We're going to look at TOR. Because you have to be a dual expert, I'm going to teach you about the cognitive walkthrough, the usability side, but also teach you a bit about TOR and how it works so that you sort of are prepared for what you'll see. We'll do the walkthrough. Then you'll have an example. You'll see what the core tasks are, what the guidelines are, and all those, basically all the details of it. And then we'll talk about assignment 2. And in assignment 2, I'll give you a piece of software, another privacy tool. You can see it already if you're curious on the Moodle, but it will be an extension that lets you sort of get some insight into cookies, which track you as you go around the internet. Cookies is also something that we'll see later in the course. And yeah, so you'll do your cognitive walkthrough for that. So next class is very important for assignment 2. So, I mean, you can watch the video, but if you're here, it's good because it will give you a head start on assignment 2. Okay, so that's it, and I'll see you all next week.